Okay, so what we're going to do now is look at a collision between two objects, two balls in this case, and see how their momentum is conserved in 2 dimensions following the collision. We're going to have ball A has a mass of 10 kilograms and a velocity of 3 meters per second. I'm going to find the momentum of this now while I'm here, and we know this is going to be m a times VA, so that's going to give us 10 kilograms times 3 meters per second. And it's going to collide with ball B. Mass 5 kilograms at rest. So I can find the momentum here really easy. That's just going to be equal to 0 because it's at rest. So plus 0 per second. However, according to the question, after the collision, let me put that here, boom. We are going to have, I'll send ball A up. I didn't really specify, but I'll put it here as such. And when you write this, we're going to make a little triangle out of this because we need to indicate the angle, and also it's going to help us when we need to break these momentums into their x and y components. And leave this space right here so that you have enough room to write, because you're going to put some things here and you're going to put some things there. Oops. So let's see what happens. We know that we're going to have the momentum after the collision at 30 degrees up, and the momentum of the second object is no longer going to be 0 because it's going to be moving, and that's going to be going down. So we're going to say that's at negative 47 degrees as such. And so what we need to do here is find the x and the y components of the momentum A and momentum B. Let's start off with momentum in the x direction first. And we know that the two momentums before the collision are acting in the x direction. So let's see what happens here. We can say that the momentum A, and this is going to be prime cosine of 30 degrees, and we'll do the same thing for momentum B. Sine at negative 47 degrees. And that's going to give us our momentum in the x direction for A and for B. And we can sum those up right here. We can say that 30 kilogram meters per second, this is from before the collision, plus 0, I'll put it here, is going to be equal to A prime cosine of 30 degrees plus momentum B prime times the cosine of negative 47 degrees. And I'm going to add these ball up here so that we can see. And remember, the mass is 10 kilograms, and it's going with some velocity. Let's see, that's going to be m, the mass of A, times the velocity of A prime. And we can stick some stuff in here and try to find some solutions. And this is going to happen right here too, though. Let's do it for both, and then we can put things in. That's going to mass of B times velocity B prime. The masses will definitely be conserved before and after the collision. All right, so let's take a look. So we know that that's going to be M A V A prime cosine of 30 degrees plus the mass of B times the velocity of B after the collision times the cosine of negative 47 degrees. Oh, that barely fits in my recorder. See if I can move this just a tad. Okay. And let's get some numbers with our calculator. Okay, so through the power of calculator, I put some numbers in here and here. And I did not put ball B here, and that's going to have a mass equal to 5 kilograms, which got inserted here, and a velocity of VB prime. Well, we can see that right there. Whoops. Let me get rid of this. No reason to have it. Okay, so we can do a little more math right here, and I'm going to pause and do that. All right, there we go. Through the power of calculator. And this is dealing with our sum of the momentums and conservation in the x direction. Okay. Well, what about the y direction? Well, we know that we are going to have, that is A. We're going to have momentum A sine of 30 degrees, and down here we're going to have momentum B prime sine negative 47 degrees. Okay, so let's deal with the y direction here. And if you look before the collision, there is no momentum in the y direction. So the sum of the momentums before the collision in the y direction is going to be 0. And that should also be the sum of the momentums in the y dimension after the collision to keep up with the law of conservation of momentum. So we know sine of 30 should look like this. We can insert our mass and our velocities in here. So we know prime sine of 30 degrees negative 47 degrees. I can insert numbers here, and I'm going to simplify. So let me pause this. You do the same. Okay, so I inserted some numbers here. And what I can do now is simplify even further. So that's going to give us 5 times the velocity A prime plus, let's see here, negative 3.65 velocity B prime. And that should all equal 0. Now I can move this whole thing this way because we're going to do a wee bit of substitution. We can simplify our values here and solve this for, what would I like to do? I can solve it for velocity b prime. I could have chosen a prime. I'm just choosing b prime for funsies. So let me do that here. I am going to start off let's divide both sides by negative 3.65. And I'm going to do this with the power of calculator. And so after simplifying, I'm going to have 1.37 VA prime as my value for velocity B prime. I am now going to take this and substitute it right here for velocity B prime. Let's do that. So we're going to have, actually, here. So let's do that. We're going to have 30. I'm going to take out the units to keep it a little cleaner. Don't tell my teacher friends. And I'm going to put this value in here, 1.37 velocity A prime. I can now solve this for VA prime. I'm going to pause and do that with the power of calculator. So that's going to be 4.66. It looks like I've already taken significant figures and thrown it out the window. Don't judge me. Let's add those together. And I can now solve this for velocity A prime. And we know that after our collision, velocity A prime, ball A, will be traveling 2.25 meters per second. Well, what about ball B? Well, I could take this value here. I'm going to write this in a different color so I don't confuse this. I can take this and now insert it here for VA. And I am going to do just that. So let's see here. Let me move this up a little bit. And so velocity B prime will be equal to 1.37 times 2.25. And I'm going to get meters per second at the end. Putting that into my calculator. Will give me 3.08 meters per second. So here is the velocity of ball B after the collision. And there's the velocity of ball A after the collision. And that is how you find the velocities to conserve momentum in 2 dimensions.